We have a homework, okay? So you are required to show that v of ax minus by will be equal to a squared vx minus 2ab covariance xy plus b squared vy, okay? And basically, you know, the most important thing is you need to know the definition of variance, okay? So this is variance. So variance, okay, the definition is here. So if you're going to check, you're going to find out variance of x, you need to calculate expectation x minus mu x square, right? And here you have, this one is the variable, okay? This is the variable. So you have this part minus expectation of this part, just like x minus mu x. So basically this is the right way to go to start. And then you have a minus x minus mu x, okay? This is a simplification. So you factor a out, and then you factor b out, okay? And here you have square, right? So this part minus this part square, you have a square minus b square, okay, a square plus b square and minus 2ab, okay? So here you have this part and this part, and here you know expectation of x minus mu x and y minus mu y, that is exactly covariance, okay? So basically, you know, if you remember the definition, then you should have no difficulty to get to the final result, okay? And let us move on. Last time we talked about covariance, right? Covariance. Covariance xy is equal to expectation x minus mu x and y minus mu y, okay? And that is equal to what? Expectation xy minus mu x mu y, right? Okay. And then how to deal with it? So we say when covariance xy greater than 0, you know, xy positively related, right? And if covariance xy less than 0, okay, they are negatively related, okay? And what means positive? When we say they are positively related, that means x and y move in the same direction, okay? When we say they are positively related, they move in the same direction. And we say negatively related, they move in the opposite direction. So let us say price goes up. Price goes up. What about quantity supply? Quantity supply will go up. Price goes down. Quantity supply will go down too. So they are positively related because one goes up, the other goes up. One goes down, the other goes down. And what about this one? So price goes up, quantity demanded going to go down. Price goes down, quantity demanded going to go up, okay? So in this case, they are negatively related, means the variables move in the opposite direction. Okay, but there is one more question, okay? So let us say, you know, in this case we use, okay, what do we use? We're going to use kilogram. So then let us say we have these two covariance, okay? Okay, so we have x. It measures in kg, okay? And then we have y measure in meter, okay? Kg. 1 kg is equal to 1,000 grams, right? It is equal to 1,000 grams. And that is equal to 100 meter, okay? No, 100 centimeter, right? 100 centimeter. Okay, so we have covariance xy, right? Okay, here it is covariance xy. And suppose we have a variable little x, okay, another variable little y. It is measured in, okay, gram, and this one is measured in cm. So this one is measured, big X, okay, big X is measured in kg, y is measured in m, but basically they measure the same thing. So covariance x, so what is the relationship between this one and this one? This one is measured in kg and measured in meter, and this one is measured in gram, g, and here is measured in cm. So can anyone tell me what would be the relationship between these two? The same thing, right? They are basically the same variable, but here it is measured in terms of kg, and here it is measured in terms of g. Can anyone tell me what should be the relationship between these two? The lady there, first lady there. Okay, so what would be the relationship here? What would be the relationship there? And you already know 1x should be equal to how many little x? One big X must be equal to 1,000 little x, right? What about one big Y? It should be equal to 100 little y, right? So then what should be the relationship between these two? So if this one going to be equal to this one, right? What you need to do? You need to divide it by 10,000, right? You need to divide it by 10,000. Okay? You need to divide it by 10,000. So what does this mean? Generally we say if covariance is larger, okay, the larger the covariance, the larger, the greater or the more closely related the two variables. But somehow, if you use different units, say, kg and g, the number is different, right? Okay? So in this case, if you simply look at the number, you are not able to tell how closely related these two variables are. So we have to use a different way, okay, a different measure to look at how closely these two variables are related. So what is that? It is correlation coefficient, okay, correlation coefficient. So what is correlation coefficient? Correlation coefficient we call rho xy. Okay, this is another Greek letter. This is another Greek letter we call rho xy. And what is rho xy equal to? It is equal to covariance xy divided by sigma x, sigma y. Okay? So for example, we say this is kg, right? Okay? And of course, sigma x, it is also kg. And this is in meter. And also this is in meter. So when you cancel all these out, there is no unit here. Okay? When you cancel all these out, then there's no unit. Okay? There's no unit. So in this case, what does that mean? That means this number will not be affected by any unit. Okay? This number is not affected by unit. Unlike this one, okay? This one you will be affected by unit. And the best of all is that there is a limit for this value. Okay? There is a limit for this value. The limit is, okay, rho xy is less than or equal to 1 and greater than or equal to negative 1. So when rho xy is equal to 1, what does that mean? That means xy are perfectly positively related. Okay? When rho xy is equal to 1, that means x and y are perfectly positively related. If they are equal to negative 1, what does that mean? That means they are perfectly negatively related. So the higher the number, okay, when it is positive from 0 to 1, the higher the number, the more closely they are related. And when they are negative, okay, in this case, I mean, when it is closer to negative 1, they are more closely negatively related. Okay? Any questions? And now we are going to prove, okay, we are going to prove why this is true. Okay, why rho xy is less than or equal to 1 and greater than or equal to negative 1. Okay. So we need to get to this. So zx minus zy, it is greater than or equal to 0. Variance, okay, for any variance, it is a square term, right? It is square term, so it is greater than or equal to 0. And what is zx? Can anyone tell me what is zx? The girl in pink trouser. So what is zx? We just mentioned, right? Standardization of random variables. So what is zx? Zx is equal to x minus mu x divided by sigma x, right? And zy is y minus mu y, okay, and sigma y. But we don't have to do this, you know, this is very tedious, okay? As a matter of fact, we all know. Zx, suppose x, the median is mu x, variance is sigma x squared, right? And y, it is mu y and sigma y squared. What about z? What is the mean of zx? What is the mean of zx? After standardization, what do we get? Next one. So what is zx? The mean, okay, the mean of zx. Have you done your homework? Next one. 0, right? 1. Okay. So this should be in your mind, okay? So then zy is also equal to 0, and variance is also equal to 1. That is a sigma y squared. Sigma zy squared, okay? So as a matter of fact, so now you're going to realize, okay, you're going to realize the formula we talk about is very important, okay? For all the formula we mentioned, you have to keep them in mind. So we talked about this before, right? V of ax plus minus by, what is this equal to? It is equal to a squared vx plus minus 2ab covariance xy plus b squared vy, right? So what is this equal to? V of zx minus zy is equal to vzx, right? Minus 2 covariance zx zy, right? According to this formula, right? And also plus vzy, okay? And of course this term is greater than or equal to 0, okay? And we just mentioned, what is this one? What is vzx? VZX is equal to 1 minus 2. Okay, here you have covariance, that is expectation, right? Expectation ZX minus mu ZX and ZY minus mu ZY plus 1 greater than or equal to 0, right? Okay, any question to this point? Here we already know standardization, it is equal to 1. The same thing, standardization, it is equal to 1. Okay, there. What about this one? After standardization, what is this one equal to? 0, right? And what about this one? 0. Okay? So, okay, so what do we get? So that means 2 expectation ZX ZY less than or equal to 2, right? Because we move this term to the other side, right? We move this term to the other side. So that means 2 expectation ZX times ZY less than or equal to 2. Okay? Any question to this point? So what is this? So that means expectation sigma x, x minus mu x, and sigma y, y minus mu y, okay, is less than or equal to 1. Okay? 2 and 2 cancel each other out, so we get 1 here. Okay? Okay, and what is this? Can anyone tell me what is this? So this is actually sigma x, sigma y, expectation x minus mu x and y minus mu y, and that is less than or equal to 1. Okay, can anyone tell me what is this thing? The girl in pink strip, red strip, what is this one? What is this one? This is rho x y, right? And that is going to be less than or equal to 1. Okay? So the same thing. If you try this, zx plus zy, the variance should be the same thing, greater than or equal to 0, right? And from there you can get rho xy greater than or equal to -1. Okay? So it is quite simple to prove rho xy, that is covariant, correlation coefficient of xy, will be between 1 and -1. And the greater the number, the more positively related these two variables are, and that's the number, to the -1, they are more closely negatively related. Okay, questions? Okay, now we're going to get to a question actually we mentioned before. Let us look at this example. So you're going to cast a coin twice, and x is the number of heads shows up. And if both shows the same, okay, you got to be very careful here. If both shows the same, then y is going to be equal to 1. If they show different, then y is equal to 2. I'm sorry, here, you got something wrong here, right? Because y should be 1 or 2, right? So the 0 there should be equal to 2. Let me see if I have done this correctly. So I have made a mistake here. So let us try this way. Okay, let's try this way. Say, if they are the same, okay, if they are the same, then y is equal to 1. if they are different than y equal to 0. Okay, so we have here, if both are the same, y equal to 1. And both are different, then y equal to 0. Okay, so forget about that. Just look at this chart. Okay, this chart is the correct one. Okay, so next time I'm going to revise it. Okay, so now we have two questions. The first question, are x and y independent, right? And the second question, you are required to find covariance of xy. Okay, look at here. So in this case, what do you get? You get x and y, okay, covariance xy is equal to expectation xy minus mu x minus mu y, but that is equal to 0. But somehow, are x, y independent? No, they are not. Okay, so this clearly shows you when covariance xy, they are equal to 0, can you be sure that xy independent? No. Okay, but if they are independent, then covariance must be equal to 0. Okay, so let us try to look at this and see how to do the problem. Okay. Okay, so x is the number of heads, and y, the same, then it is equal to 1, right? And different, then equal to 0. Okay, so we have two possibilities. We have 4 outcomes. Head, 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 tail, tail, head, tail, tail, right? Okay? And then x and y. So here x is equal to 2, right? And they are the same. Okay, they are the same, so y is equal to 1. They are different, right? Equal to 0. 1, because there is one head. 1 head. 0 head. Okay? And then you have 0, 1. So the next step, you are going to get a table, right? So x and y, right? 0, 1, 2, and y going to be 0 and 1. Okay? Okay, so we get to Mr. Zheng. Okay? What is the probability here? What is the probability here? 0, 0. 0, right? Because you cannot find anything 0, 0. Okay? When x is equal to 0, y is equal to 0, it never happens. So the probability is 0. What about x equal to 1 and y equal to 0? How much? X equal to 1 and y equal to 0. 1/2, right? Because here, x equal to 1 and equal to 1, 0 and 0, so 1/2. Okay, and x equal to 2, y equal to 0. 2, 0, 0. Okay? You are lucky it is not exam now, right? When you are doing the exam, try to be very careful. Okay, the girl in purple coat. What is here? X equal to 0 and y equal to 1. 1/4, right? 2, x2 and y1, right? 1/4. What about here? X equal to 1 and y equal to 1. 0, okay? And then x equal to 2, y equal to 1, 1/4. Okay, so very clear, when y is equal to 0, the probability is 1/2, y equal to 1, Probability the same thing, 1/2. Okay? And now you are trying to get the probability for x, right? When x equal to 0, 1/4, 1/2 equal to 1, and 1/4. Okay, so the same thing, right? Basically the same thing. If you just try to be very careful, you should get the same kind of result. Okay, now the question is, we are trying to calculate expectation of x minus mu x and y minus mu y, right? But we know that this one can actually be simplified to expectation xy minus, okay, mu x, mu y. So when we have expectation x, what is that? Summation x minus, plus, times, okay, x times px, right? And what about here? Expectation xy. Then what do you have? You had summation, right? xi, yj times p, xi, and yj, right? Okay, so you got to remember, okay? You know, the formula is the same, but now the variable is not x, it is x and y. So you have to have two probability there, right? Okay, I mean, in terms of the function, it has two variables. Okay, in terms of the function, it has two variables. Okay, can anyone tell me if this is the case, then how are we going to do it? Okay, so of course the first thing is to calculate mu x. The first thing is to calculate mu x. The second is to calculate mu y. Okay, so now let us try to get mu x. So mu x is actually, we have done it several times. What is mu x? Mu x is equal to 1, right? Okay. What about mu y? 0 times 1/2, you get 0. 1 times 1/2, you get 1/2. So that is equal to 1/2. Okay? So very clear, mu x times mu y, that is equal to 1/2. But what about this one? Can anyone tell me how to get expectation xy? So, okay, you have shaken your head too early. The next one. How to get this? The answer is here, right? xi yj times p xi yj. So how to do that? First you have to have 0 times 0 times this one, because this is xi yj pxij, right? pxiyj, okay? But you know this is 0, so you get 0, right? Forget about it, okay? 0, 0, 0. This is the first part. What about the second part? 0 times 1 times 1/4. What do you get? You still get 0, okay? What about this one? 1 times 0 times this one, you get 0, okay? 1 times 1 times 0, you get 0, okay? What about this one? 2 times 0 times 0, what do you get? You get 0. 2 times 1, 1/4. So you get 2 times 1 times 1/4. So that is 1/2 minus 1/2 equals what? 0, right? Equals 0. Okay, so indeed, in this case, covariance xy is equal to 0, right? So covariance xy is equal to 0. The second thing we want to verify is are xy independent? Are xy independent? So let us get to this lady there in the gray shirt. So are xy independent? Are xy independent? Excuse me? No. Why? How to verify two variables, whether they are independent or not? So Px times Py, are they equal to Pxy, right? Okay? And here, actually, you can see there's something wrong here, okay? So, because x has three possibilities, three numbers, y, two numbers. So let's get here. So Px equals 0 times Py equals 1. What is this equal to? What is this equal to? Px0 is equal to 1/4, right? Y equals 1? 1/2. So what is that equal to? 1/8. But when x equals to 0, y equal to 1, what is that? 1/4. Are they equal to? Is this equal to 1/4? No, it's not, right? So in this case, it shows you that even when the covariance of x, y, they are equal to 0, but what happened to the variable of x and y? Are they independent? No, they are not independent. The easiest thing to verify is when two variables, okay, they are mutually exclusive, okay? When there are some cases they are mutually exclusive, then they must be what? They must be dependent. So they are mutually exclusive here, right? And mutually exclusive here, and mutually exclusive here. So what does that mean? That means they must be dependent. So dependent means not independent. Okay, so let's take a break. So we discussed one example showing you exactly why when covariance xy is equal to 0, still xy are not independent. Okay, so here it is the example here. Okay, now we get to review questions. These are the midterm tests of this year. Okay, so when with probability of 0.3, a passenger will bring metallic materials. Okay, sometimes even the bell, right? This part is made of metal. Okay, so when you pass through the security of the airport or any other places, it will ring. So because you have metal, okay? But sometimes, machine will make mistake, right? Sometimes machine will make mistake. For example, sometimes I don't have anything that is made of steel or other metal, but still the bell rings. But they're gonna double check me, right? So we use a bar, to double check my body, see if there is any metal in my body or in my pockets. It cannot find anything. So sometimes machine make mistake, right? Okay. So sometimes when you don't have anything, but it rings. Sometimes you have something, it doesn't. Okay. So sometimes it's the other way around. Okay. Sometimes you don't have anything metal. Okay. It rings. Sometimes you have metal with you, but it doesn't ring. Okay. So when it rings, it means sometimes you have metals with you, sometimes you don't. Okay. But here we talk about person first. Okay. So for any person with probability 30%, that is 0.3, it will bring metal with him. Okay. And 0.7 otherwise. Okay. So 30% I will bring metal with me. 70% I don't. Okay. And then a metal detector can detect metallic materials with probability of 0.93. Okay, so the accuracy rate is 0.97. What does that mean? If they are 100%, okay, they carry metal with them, how many people I can detect? 97. Okay, the correct rate is 97%. If such metal exists, okay, but with no metallic materials exists, the detector may show warning at probability 0.05. So what does this mean? This is false warning. Okay, this is false warning. You don't have anything metallic, but it sounds. Okay, the bell rings. So the first question, what is the probability that a person may be detected of metallic materials? Your turn. So what is the probability a person may be detected of metallic materials? So one thing is you bring metallic materials with you and it got detected, right? And the other is, because the question says, what is the probability that a passenger may be detected of metallic materials? We also talk about false alarms. So there are two cases. The first case is that you do have metallic materials with you and the machine rings. Okay, this is the first case. What's the second case? You don't have any metallic with you, right? You don't have any metallic materials with you, but the machine also rings. Okay, so what should be the probability there? Tell me how to calculate it. Tell me how to calculate it. That's it. You don't have to tell me the number. What's the chance this person gonna bring metallic material with him? 0.3, right? So 0.3 is the probability this person gonna bring a metallic material with him. And when this person brings metallic material with him, what's the probability the machine will ring? What's the probability there? Miss Dunn, Miss Lai. So in the exam, there are all sorts of words. Okay, there are all sorts of words when you are required to turn the words into formula, right? Conditional probability, whatever. Okay, random variables. So this person gonna bring material with him, metallic material with him. 0.3. Okay, when he carries metallic material with him, what's the probability that the machine will ring? 0.97. Okay, so this person has metallic material with him and also the bell rings. It is 0.3 times 0.97. This is the first part. The second part is the false alarm. What is the false alarm? This person doesn't bring metallic material with him, but the bell rings. So that is 0.7 times 0.05, right? Okay, second question. When a passenger was detected of metallic materials, what is the probability that, indeed, he carries such items? Ms. Ren. So we just talked about the first case, he did bring, okay, he did bring something with him. The second case, he didn't, right? So we already know the probability that the bell gonna ring, okay, the alarm gonna sound, okay? The alarm gonna sound at the probability of question 1. That is the answer of the question 1. The question 1 say the probability the bell will ring, okay? And then the bell will ring according to two parts. One part he carries something, the other part he doesn't, right? And so here we are talking about what's the probability given the bell already rings. What's the probability that he indeed brings something with him? So that is 0.3. This is the probability he's going to bring something with him, right? And times 0.97. Indeed, the bell rings, okay? And divided by the answer, okay, in question 1. Here, okay? So 0.3 times 0.97. He carries something and the bell rings. The second one, 0.9 times 0.05. He doesn't carry anything, right? But the bell ring. Okay? So the whole probability is 0.326. This is the probability the bell will ring. Okay? And then, given the bell already ring, okay, given the bell already ring, what's the probability he carries something with him? So that is 0.3 times 0.97 divided by 0.326. So what is this? Conditional probability. Okay, conditional probability. Any question? Or would you like to need more time to take it down? This part or this part? Or both? Okay, give you 2 minutes, okay? So basically this question, so in the meantime, let me continue to elaborate, explain what's going on here. So the question looks like very long, right? The question looks like very long, but it's very easy, okay? It is a conditional probability. Okay, the machine may mistake. Okay, so this person may bring something, he may not. Okay, but when he brings something, the machine will ring at certain probability. And when he does not, okay, the machine will ring at another probability. Okay, so the question is, when the bell already rings, okay, what's the probability? Okay, the first question is, what's the probability the bell will ring? The second one is, when the bell rings, okay, what's the probability that he indeed brings something with him? Okay? Questions? Another thing that we, let me tell you a little bit my experiences. Sometimes, you know, there is a technique to take down notes. So for example, this question is so long, right? And you want to take down word by word. Can you do that? Absolutely not. So what you're going to do? Actually, you need to use some shorthand. What means shorthand? It doesn't mean your hand is short, okay? It is totally different. That means you use some notation. So for example, here, you know, when I type all these things, I think it is very tedious for me to type probability every time. So what do I use? I use prob. So in terms of you, when you want to take notes, maybe you should use only P, right? That is even easier, okay? So 0.3 for for bringing something, 0.7 for not bringing, and then detecting 0.97. Not detecting 0.05. Okay, so here, just some example that I share with you. Also, when because my major is political science in my undergrad, and in political science we have a lot of terms, and it's quite long. For example, we talk about Napoleon, institution, organization, governments. Okay, these words are very long. How can I take notes? I only use shorthand. So for example, when I'm talking about governments, I only use G. Okay, G is government. And I use institution, right? I use INS for institution. And Napoleon, okay, either in terms of Chinese, 3 words, right? Napoleon. And even in terms of English is even much longer, right? So I only use 1 word, N, for Napoleon. So sometimes you need to use shorthand to take notes. Okay? Next question. This one is a little bit more difficult. I mean, not really difficult, but in this case, you have to use a Venn diagram. Okay, so let us try here. Okay, so let's try this diagram. So we have 40% of people join A club, and 35% join B club, 28% C club, and 15% join A and B, 12% A and C, 13% B and C, 10% A, B, C, okay? So 10 is here, right? 10%. A and B and C, okay? And, okay, so the question is, the first one, what's the percentage one does not join any club, okay? So the point is, we need to fill in all the numbers. So we have 15% A and B, right? 15% A and B. So what should be here? How much should be here? Mr. Ren, how much should be here? 15% join A and B. So how much should be here? Excuse me? I beg your pardon? Could you speak louder? 2%? Are you sure? 15% join A and B, right? 5. Okay, 5%, right? Can anyone tell me how much it should be here? B and C, how much for B and C? 3%. So B and C must be 13%, right? What about here? A and C, right? A and C. 0%? Excuse me? 2%. Okay. So this is total 10, 5, 2, 17, right? How much for A? How much for A? 40, right? 40% join A. So how much should be here? How much? 23, right? So basically this kind of question, you just fill in the blanks. Okay, fill in the blanks. What about B? How much for B? 35, is that right? 35, so how much should be here? This is 18, and this 35, right? 17, right? What about here? For C, it is 28%, right? 28, you have 15. So 13, right? 13. Okay. Now the question, the first question say, you know, what's the percentage one does not join any club? So for all the people join one club, it is here. Okay, at least one club. So this is 40%, right? 40 plus 20 plus 13. So you have 73%, okay? So what's the percentage of the people that does not join any club? It should be 1 minus P, A, or B, or C. So what is that equal to? 27%, right? Because the chart you are looking at least join one club, right? Either A or B or C, okay? So if you want to get not in A, not in B, and not in C, right? So you have to 1 subtract all these. So that should be equal to, because, okay? This is, let us say this is equal to D, right? So for D, it is either in A or B or C, right? And we are looking at not in this one. So that is what? Remember we say complement, right? Complement, okay, complement. So that is 1 minus the other one. And D plus D bar should be equal to 1, right? Probability of D plus probability of D bar should be equal to 1. Okay, any question? So if you draw a picture, right? The whole thing is the sample space, right? The whole thing is the sample space, and it includes two parts. One part is for those join the club. The other part is the person does not join the club, right? Any club, does not join any club. So here, if you get inside, okay, inside this circle, what's the percentage? The percentage is 73, right? So what about outside? Outside should be 27, okay? The second question say, what's the percentage of joining only one club? Okay, this is only one club. The gentleman there. So what's the percentage that of the people join only one club? $23? 43? Okay. So it is this one, right? Only one club. For people here, it joins two clubs. Here join two, here join two, here join three. Okay? So only one club. This part, and this part, and this part, right? Okay? So if you look at the chart, if you can get this picture done, you should have no questions. Okay? So if a person joins A, what's the probability he also join B? So that means if we already know this person joins A, and what's the probability he joins B, right? So it should be PA and PA and B, right? So that should be equal to 40%, A and B, 15%. Okay, so you get the answer. Okay? Questions? Any questions? So basically this is the answer, okay? Okay, here is another question. Okay, we have a table here. Okay, so X 1, 2, 3, Y 0, 1, 2. Okay? And so when we get all these, so probably I'll give you 1 minute to take this down. Okay, give you 1 minute to take this down. And okay, probably let me take it here. Okay. Okay. Questions? Anyone? Miss Wang? Are you all right? If you haven't finished taking it down, raise your hand. Everyone done? Okay, so let us look at the question. So what is the question there? The first question, find expectation of y. Okay, the second question, find expectation of y. The third one, variance of x. The fourth one, variance of y. The fifth one, variance of 2x minus 3y plus 10. The last one, find covariance xy. And then the seventh one, find rho xy. Eighth one, find the conditional mean. Okay, when y equal to 2, what is the mean of x? And when y equals to 2, what is the variance of y? So basically, it's just from this chart, okay, from this table, okay? So when y equal to 0, okay, when y equal to 0, the probability is 1/5. Y equal to 1, 2/5. y equal to 2, 2/5. X equal to 1, 3/10. Equal to 2, 4/10. Equal to 3, 3/10. So basically from here you should be able to get expectation X, expectation Y, variance of X, variance of Y. You should have no difficulty here. I don't want to show that again. And then we are talking about covariance, okay? So let us look at this. Question 5, okay? Variance 2x minus 3y plus 10. In terms of formula, okay, because it is a function of random variable, so we talked about this before. We say when w is equal to ax plus by, then what is vw? Vw is a squared vx plus 2ab covariance xy plus b squared vx, right? B squared vy. So basically, you should be able to tell me in terms of the formula, okay, and the relationship between variance x and variance y. Okay, so question 5, your turn. So what should be that equal to? Question 5. Next one, I mean the girl in black shirt. Even though we have two, but it is you. Okay, Mr. Wu. Question 5. What should that be equal to? In terms of Vx and Vy. Tell me the simple way. It should be 4Vx, right? 4Vx plus 9Vy minus 12 covariance xy. So let me repeat this again. V of 2x minus 3y plus 10. What should be this equal to? 4 times variance of x plus 9 times variance of y minus 12 covariance xy, right? And the calculation of covariance xy we just showed that a few minutes ago, right? And rho xy, it is covariance xy divided by sigma x and sigma y, okay? Okay, the difficult part is the standard deviation, okay? The conditional mean and conditional variance, okay? So when y is equal to 2, okay? When y is equal to 2, what's the probability that x gonna be 1? Okay, let me repeat this again. When we already know y is equal to 2, right? We already know y is equal to 2. Now, what is the probability that x is equal to 1? Okay, 傅政委. We already know y is equal to 2. What's the probability that x is equal to 1? It is a conditional probability, right? Next one. We already know y is equal to 2. What's the probability that x is equal to 1? This is very simple, right? You've got to be able to do this, otherwise Miss Wang, we already know y is equal to 2. What is the probability x is equal to 1? Excuse me? 1/2, right? Because y is equal to 2, right? Okay, y is equal to 2 here. Okay, here, right? And x is equal to 1. It is 1/5. So 1/5 divided by 2/5. So what is that equal to? 1/2. Okay? So when you apply conditional probability, conditional mean, conditional variance, just try to be careful. You are applying a different probability. Okay. So this is the solution. Okay. So because I already explained, so I don't want to go over this again. Okay. Questions? Here it is a example, okay, about the property of properties. Okay, the property of probabilities. We say for any event, okay, for any event, the probability must be greater than or equal to 0, right? And for the whole thing, the probability should be equal to 1, right? We say for anything, okay, for any event, the probability must greater than or equal to 0. And for all of the events, the probability must be equal to 1, okay? So here we have a probability, a random variable. X can be equal to 1, 2, 3, 4, 5, 6. And probability of x equal to 1, we get k equal to 2, k over 2, 3, k over 6, 4, k over 2, 5, k over 3, and 6, k over 2. So, what is k? The gentleman behind Ms. Wang. So what is k? How to get k? I just mentioned, right? K at least has to be greater than or equal to 0. And all of the probability must be equal to 1, right? So what is this equal to? What is this equal to? So let me ask you, if you add px equal to 1, px equal to 2, etc. to px equal to 3, what should be the probability equal to? The probability should be equal to a number, right? What should that be? So if you have px equal to 1, px equal to 2, add together up to px equal to 6, what should be the whole thing equal to? If you add all these numbers together, all these probability together, what should be that equal to? Okay, we have another wrong. Your turn. So if we add all the probability together, what should be that equal to? Equal to 1, right? So what does that mean? K plus k over 2 plus k over 6 plus k over 2 plus k over 3 plus k over 2. What should be these equal to? Equal to 1. Okay? So because of the properties of probability, if you add these numbers together, you get 1. So you have an equation and only one unknown. Okay, one equation and one unknown. Then you should be able to get k. Okay? And now, because you can solve for k, so you know k. And now, of course, you know y is equal to 2x minus 5. And because in question 1, you are able to solve for k, that means you are able to get the probability of x equal to 1, probability x equal to 2, etc. So you should be able to get variance of x and mean of x, okay, the expectation of x. And now you know y is equal to 2x minus 5. So what is expectation of y? Expectation of y is equal to 2 times expectation of x minus 5, right? Expectation of y is equal to 2 times expectation of x minus 5. Okay, and what about variance of y plus 15? Okay, can anyone tell me in terms of a formula what is variance of y plus 15 equal to? The next girl. So what is v of y plus 15? What is that equal to? It is actually equal to v of y, right? Because if you add a number or subtract a number, does it affect variance? No, it doesn't, right? If you add a number or subtract a number, does it affect variance? It doesn't, okay? Okay, questions. So now the first question, okay, the answer for the first question, and now you get the second and the third. Let us take a break.